Hold on tight, a giant of the cosmos as big as a city bridge is zooming towards Earth. This isn't your everyday space rock, we're talking about an asteroid so massive it's making headlines and turning heads at NASA. Coming in hot at a nail-biting distance of just 5.5 million kilometers, this celestial behemoth is the talk of the town in the world of astronomy. In this video, we're not just watching from the sidelines, we're diving deep into what makes this asteroid a cosmic superstar. Get ready to uncover its secrets, learn why it's causing such a stir, and see how the Guardians of the Galaxy keep an eye on these sky-high speedsters. Strap in, we're about to embark on an interstellar adventure. Asteroids, the rocky remnants from the dawn of our solar system, are more than just space debris. These celestial bodies orbiting the Sun, primarily between Mars and Jupiter, are the leftovers from the formation of planets over 4.6 billion years ago. Composed mainly of rock and metal, asteroids vary in size, some as small as pebbles, while others, like the one near Earth, are as colossal as mountains. There's a diverse cast in the asteroid family. The most common types are C-type, carbonaceous, S-type, siliceous, and M-type, metallic. C-types, the most prevalent, are dark and carbon-rich, residing mostly in the outer regions of the asteroid belt. S-types, made of silicate materials and nickel iron, are found in the inner asteroid belt. M-types, rich in metallic iron, are rarer and dwell in the middle belt. Asteroids play a crucial role in our solar system. They're time capsules holding clues to the solar system's formation and evolution. Studying them helps us understand the building blocks of planets and the origins of water and organic compounds on Earth. The history of asteroid exploration is a tale of curiosity and innovation. It began in the early 19th century with the discovery of Ceres, the largest asteroid, by Giuseppe Piazzi. Since then, missions like NASA's Dawn, which explored Vesta and Ceres, and Japan's Hayabusa missions, which returned samples from asteroids, have expanded our knowledge exponentially. Notably, the OSIRIS-REx mission's recent sample retrieval from Bennu and NASA's DART mission, aimed at testing asteroid deflection, highlight our growing capabilities in not just understanding, but also interacting with these space rocks. As we marvel at the wonders of asteroids, it's crucial to acknowledge the Vigilant Guardians who keep a watchful eye on these celestial travelers. NASA and its Advanced Network for Tracking Near-Earth Objects, NEOs. This vigilant monitoring is not just about awe and wonder, it's a critical task to ensure our planet's safety. NASA employs a suite of sophisticated techniques and technologies to track and catalogue asteroids. Ground-based telescopes and radar systems, along with space-based observatories, form the backbone of this surveillance network. These tools scan the skies, capturing data on the size, shape, composition, and most importantly, the trajectory of NEOs. This data is then analyzed using complex computational models to predict the paths of these objects and assess any potential risk they pose to Earth. Calculating asteroid trajectories is a delicate science. It involves understanding the gravitational influences of other celestial bodies and the subtle effects of the sun's heat on the asteroid's path, known as the Yarkovsky effect. This information helps scientists determine whether an asteroid's orbit could intersect with Earth's orbit, posing a potential impact risk. NASA's history with near-Earth asteroids is filled with notable events. For instance, the close approach of asteroid 99942 Apophis in 2029, once considered a potential threat, has been the subject of extensive study. NASA's calculations and observations have reassured us that Apophis will safely pass by Earth. Similarly, the agency played a crucial role in studying the Chelyabinsk meteor in 2013, which exploded in Earth's atmosphere, underscoring the importance of tracking even smaller objects. Now, the asteroid community is abuzz with excitement over a bridge-sized asteroid, making a close approach to Earth. This particular asteroid, notable for its impressive size, is a prime example of the larger members of the Near-Earth Object NEO family. Comparable in size to a large urban bridge, it stands out among the thousands of smaller asteroids that routinely pass by our planet. The physical characteristics of this asteroid, including its exact size, composition, and rotation speed, are of keen interest to scientists. These details not only provide insights into the asteroid's history and origin, but also contribute to our broader understanding of asteroid formation and behavior. Observations from telescopes and radar measurements are crucial in gathering this data. The orbit of this asteroid is particularly intriguing. Its trajectory, which brings it relatively close to Earth, offers a rare opportunity for detailed study. By analyzing its orbit, scientists can refine their models of how gravitational forces within the solar system influence the paths of NEOs. This asteroid's approach is also an excellent test case for tracking systems and predictive models. Comparatively, this asteroid's close approach is significant, but not unprecedented. It joins the ranks of other notable asteroids that have passed near Earth, each providing valuable data and insights. What makes this event stand out is the combination of the asteroid's size and proximity, offering a unique opportunity for study. The prospect of an asteroid impact on Earth, while statistically low, carries potential consequences that are significant enough to warrant global attention. An impact, depending on the size and speed of the asteroid, could lead to catastrophic events ranging from localized destruction to global climate effects. The 1908 Tunguska event and the more recent 2013 Chelyabinsk meteor are a stark reminder of the damage even smaller asteroids can cause. In response to these risks, global efforts in asteroid deflection and Earth protection strategies have gained momentum. One notable initiative is NASA's Double Asteroid Redirection Test, or DART, mission, which is aimed at testing the kinetic impactor technique to change the motion of an asteroid in space. Similarly, the European Space Agency's Hera mission is set to study the aftermath of the DART impact, providing valuable data for future deflection efforts. These missions are part of a broader strategy known as planetary defense, which involves detecting, tracking, and characterizing NEOs, and developing methods to mitigate potential impact threats. This field has seen significant advancements in recent years, thanks to improvements in telescope technology, radar systems, and computational models for predicting asteroid paths. International collaboration is the cornerstone of effective planetary defense. No single nation can shoulder the responsibility of monitoring and mitigating asteroid threats alone. Collaborative efforts like the United Nations Committee on the Peaceful Uses of Outer Space and the International Asteroid Warning Network facilitate the sharing of data, resources, and expertise among countries. This cooperation is crucial not only in advancing our understanding of asteroids, but also in ensuring a coordinated response in the event of a potential impact threat. At the same time, the exploration of asteroids is entering an exciting new era, with several important missions and projects lined up. These efforts are set to deepen our understanding of these space rocks. First up, NASA's Psyche mission is a game changer. It's the first mission ever to explore a metal-rich asteroid. The target, named Psyche, is thought to be the exposed core of an early planet. Studying it could tell us a lot about how planets, including Earth, formed. This mission is a big deal because it could answer some key questions about our solar system's history. Then there's NASA's Lucy mission, which has a new target in its sights. In early May 2023, Lucy will get up close to a small asteroid, adding another exciting chapter to its journey. Lucy's main job is to explore the Trojan asteroids near Jupiter, which are like fossils from the early solar system. This mission is like a time machine, giving us a glimpse into the distant past. The OSIRIS-REx mission, which grabbed headlines for bringing back samples from asteroid Bennu, isn't done yet. It's now on a new mission called OSIRIS-APEX to check out another asteroid, Apophis. This mission is important because it helps us learn more about different types of asteroids. Projects like the Near-Earth Object Surveillance mission and the Large Synoptic Survey Telescope are also crucial. They're like giant space watchdogs keeping an eye on asteroids that might come close to Earth. These projects help us stay safe by tracking these space rocks and figuring out if they're a threat. Lastly, there's a growing interest in asteroid mining. This isn't just science fiction anymore. The idea is to get valuable resources like metals and water from asteroids. This could be a big deal for future space missions, giving us the supplies we need for longer trips or even deeper space exploration. As our interstellar adventure draws to a close, remember the journey through the cosmos is far from over. This colossal asteroid, a mere whisper away in cosmic terms, is just the beginning. It's a reminder of the vast, uncharted mysteries waiting out there. So keep your eyes on the skies and your mind open to the wonders of the universe. Who knows what other secrets are hurtling through the stars, ready to be discovered?